Okay, welcome back to the episode of Discrete Math, all you cool cats and kittens. Okay, so today we're looking at the Babylonian Numerals. Okay, so we've been talking about the Hindu Arabic system for a while now. The digits are obviously 0 through 9, that we use now. Okay, the key thing here to notice that it is that position, the Hindu Arabic system is position 10, okay, or base 10 that we use. Okay, that 10 is important, okay, because we are no longer working with base 10 when we talk about Babylonian. Okay, now, expanded form, which we better numerator the system, off of the first is bit 1, and then 10 to the first, 10 to the second, and so on. So, for example, let's look at 1523. Okay, this here digit, the 1 there, is 1 times 1,000, plus 5 times 100, plus 2 times 10, plus 3 times 1. Okay, and we have been doing this the whole time. Okay, we're decomposed. So let me just rewrite this again so I can show you what exactly I'm referring to here. Okay. And again, I'm sorry that my handwriting is not the most prestigious. Okay, but I can also take this here and I can also rewrite it like this. Okay, the first one is the first power, right? So that's 3. Okay, the second one is 10 to the 0, or 10 to the first, I'm sorry, because this is 10 to the 0. Okay, because we don't know anything to the 0 power is 1. 10 to the first would be 2. And then we get 10 squared is the 5 there. And then the 1,000 with the 1. Okay, or 10 cubed. Okay, this would be important to talk about change of base. So I'm just kind of alluding to it now so I can bring it back later. Okay. But this here is what I wanted to show you this here. 10 to 0, 10 to the 1, 10 squared, 10 cubed, that's just 1, 10, 100, 1,000. Okay? So now we're talking about Babylonian, we're doing base 60. Okay? And this is not a true place-value system because it lacked a symbol for 0. Okay? That, when we talk about the history of mathematics, that's pretty important, because we've been talking about all these systems, the Egyptian, the Romans, and the Chinese, and now the Babylonians, and the iconic Greek. And we're talking about what 0 really is. Okay? So there's only 2 symbols in this at the beginning of this, 1 and 10, that's it. Okay, so here this powers would be 60 to the 0, which was all 1, 60 to the first, 60 squared, 60 cubed, and so forth. Okay? A gap is left between them to distinguish place values. We go from right to left. And so kind of probably better just to show you. So here we have this example, right? I have my key in front of me so that way I don't have to keep referring back to other slides. So if I look here, if I break this down here, this numeral here is 2 arrows in the thing, so that's the number 21. Okay, because each of those little things are 10. Here, this would be, what, 34? Okay. But now we're still not done. We don't add those because remember there's a gap right here. Okay, so that tells you that's a positional change. So I have to multiply this here by 1 and this here by 60 to the first is just 60. Okay, so when I do 60 times 34 I get 2040 plus, and 21 times 1 is just 21. So this numeral is going to be 2061. And that's your final answer. Okay, let's do another one. Okay, it probably would have helped if I would have put the key on each of these slides, but that's alright. Okay, so we should know that the arrow things, that's 10, which can't tell what that says. That's 10, and then the staffs are just 1, they look like a 1, so that's how I remember it. Okay, so this here would be 31 then, and I see a gap right here, and this here would look 21. 21. Okay, because there's a gap that means there's positional change. So this here gets multiplied by 60 to the 0, 1, and this here gets multiplied by 60 to the first. Yeah, 60 to the first. So 60 times 21 will be 1260 plus 31 to give me my final answer of 1291. Okay, you can think of this break here like a plus. We know we have to add them. Now I'm bringing one more symbol. This is the last symbol we have for this one. It's a subtraction symbol. So if I look at this example here, we know we have, it looks to be here like a 10, right? So we have 10, but then we have that subtraction sign. So 10 minus 2. That gives us 8. And then it's kind of hard to see, but there's a brick and there's another symbol there, which is a 1, right? So here, if I bring this up here, we have a 1 in the 60th place, plus, and then we have 8 in the 1's place. So 60 times 1 is 60, plus 8 times 1 is 8, so 60 plus 8 is going to be 68. So it's the same thing like I've been doing before, but now I had to do subtraction, because this is subtraction built within it right there, because of the new symbol. Okay. So another one, right, the number 126 is a Babylonian. Now I find it can be very difficult to go from Hindu Arabic to Babylonian, so my recommendation here is just to go back and work all the choices out. So here we know we have 1, 2, 3, 4, 5, 6 here, and 2 here, right? And this is in the 1's place, so 6 times 1 is going to be 6, and then 2 times 60 is 120. With them you actually get, look at that, A is actually the answer. Okay, so that was convenient for us. But my test taking strip tip here would just be work out all the choices. I don't really have all that room. But like, let's work out D, for example. So D here we have 1, 2, 3, 4, 5. So we have 6 here and 1 here, right? This is in the 1's place. So 6 times 1 is 6. And this would be 60. So this is actually 66. And not 126. Okay. Right, the Babylonian Numerals, Hindu Arabic. So now we're going back again. Now here, it's very important to know, so we have 2 gaps, right? So we know that whatever we get here, we're going to multiply by 1. Whatever we get here, we're multiplying by 60. Whatever we get here, we're multiplying by 60 squared, or 3,600. Okay? I didn't finish the problem, so I have to pull up the calculator. Okay, so here we have, what, 10, 20, 31. Here we have 40. And here we have 2. Okay, so here, I think this is 7,200 in my head. 60 times 4 is 24, 2 zeros, plus 31. You add these together now, and you get 9,631. The final answer, okay, because I broke it up there and did my 3 sections there because there's 2 gaps. Again, first position, second position, third position, multiplied them to get these, and then summed it at the end. Okay, so now let's look at this one. There's no gap, whatever. So whatever I get, multiplied by 1, that's my final answer. So we have 10, 20, 30. 34 times 1 is just 34. That was a quick problem. Okay. Here we have a gap, so we'll get here multiplied by 60, we'll get here multiplied by 1. Okay, it could be kind of confusing because of the division sign, but I'm trying to do the place value systems for you guys. So here we have a 3 here, and we get 30 here. So 60 times 30 is 1800 plus 3, so it would be 1830. Okay, I'll do one more. Okay, here's again the situation you get of Hindu Arabic to Babylonian. So what I'm going to do is I'm going to just work the choices out. So let's start with A. So if I look at A, I have, A down here. First, and then 60. So we have 10, 1, 2, 3, 4, 5. So 15 here, and then 10, 12 here. Okay, so let me put my hand in the calculator now. Possibly. Calculator. Okay. So, got my calculator. Okay. So now if I do this, we have 12 times 60, 720. Plus 15 is actually 735. So it turns out actually this is also A as well. Okay, but again, if it wasn't A, you could go to work B, and C, and then D, until you got the answer you needed. Okay.